Okay, section 2.5 on page 209 talks about graphs of functions. Write the domain and range of each function. Use interval notation wherever possible, otherwise use set builder notation. Remember, domain and range deal with the x and y. Domain, allowable x values. So I'm trying to look on the x-axis. If I take this path left to right, the x runs how far? It seems x starts at -6 included, running all the way to 0. This is x equals 0. And do you see how that's an open circle? That's not included. The range is looking at the y. So it's looking, as I take this path left to right, it's looking at how high or low do I run. So you notice if I start right there, I'm going to run down and go back up, but still, nevertheless, I'm not going to go beyond those points. I'm going to erase those not to clutter the graph. So the range is really running between. It goes as low as a -4, and it seems that's included. And it goes up to -1. It's included right there. That's sufficient. Even though it's not included there, it doesn't matter. If one of those includes it, automatically it's included. So, number 4 is the next. Keep in mind how this author draws, or how they draw in this book. This really indicates there's an error there and an error there. So if you say what's the domain, you're looking at the allowable x values. You trace this graph left to right. Do you notice on the x-axis, you're really coming all the way to this x? So this is going to run -infinity all the way. Isn't that 1? Do you see it's not included? Anytime you have more than one interval, union. And doesn't that begin from 2? But it's included. And this is going to run all the way to infinity. That's domain. Range. If I look at not the x, the y, that is up and down. If I take this path, doesn't this run all the way down? -infinity all the way to this value. So it's going to be -infinity to, isn't that -1 right there? And do you see it's not included? And then you skip a gap and you pick right there. And if you're looking at the y, isn't that right there y equals 0 included? And isn't this going to run all the way up to infinity? And there it is. If I look at number 6, again, those are arrows. If I look at the domain, basically if I take this path left to right, doesn't this run all the way to -infinity? And this is going to keep on running all the way to infinity. So the domain would be all real numbers. Anything will work. That's looking as far left and right this graph would run. What if I look at the range? The range is the y. If I take this path, I'm trying just to see how high does it go up and how low does it go down. Doesn't that run as high as 1 and as low as -1? And it seems to be included. So always smaller to larger. And if I look at the last problem, again, keep in mind that's an arrow. If I look for domain, domain is allowable x values. If I take this path left to right, do you see along the x-axis, this is going to start right there, and it's going to run all the way to the right? So domain, 0 to infinity. If I go back and do the range, on the other hand, taking this path, it's looking at the same thing, except it's looking on the y. How high or low does it go? Do you see this goes up to this point, but doesn't go above that? And it's going to run all the way down. So wouldn't that be -infinity? And it's going to run as high as 4 included. On the next set of problems, number 10 and 12, it says, use the graph, evaluate f of 0. Again, keep in mind how this works. F of x, there's x, and the y is f of x. So when it says, what's f of 0? It's saying when x equals 0, kind of like if x equals 0, what does y equal? Graphically, x equals 0, you're looking at the graph and saying, well, if x equals 0, isn't that this point right there? So if x equals 0, what's the y? Negative 2, which indicates that f of 0 is negative 2. There's the first answer. And notice what this says. This says f of x equal negative 5. Didn't we say this was y? So this is saying, what if y equals a negative 5? Graphically, y equal negative 1 is a horizontal line, 3, 4, horizontal line right there. If you draw y equal negative 5, which is f of x equal negative 5, isn't that point negative 1, negative 5? So wouldn't that be a negative 1? So if f of x equal negative 5, that's when x equal negative 1. That's the answer to the second part. If I look at this problem, evaluate f of 0. This is saying when x equals 0, what does y equal? So think of it this way. 0, what would y equal? Well, where's x equals 0? X equals 0 is a vertical line right there. Isn't that the point 0, 1? So that's y is 1. And here when it says f of x equal negative 1, if f of x equal negative 1, they're saying, well, what does x equal? This means when y equal negative 1. If I go to y equal negative 1 and I draw a horizontal line, so x equals 0 is a vertical line, y equal negative 1, what's that point? Isn't that point 2, negative 1? Since I'm given y, I'm looking for x. X would be a 2 in this case. Another one of those. This says f of 4. If they say f of 4, they're saying when x equals 4, what does y equal? That's what this is. Well, x equal 4. Isn't x equal 4 a vertical line? Where does that cross the graph? Isn't that point 4, negative 1? So this is a negative 1. Again, there's the x, and the whole thing is always y. Notice here the whole thing is negative 3. This is saying y equal negative 3. If you draw y equal negative 3, isn't that a horizontal line right there? Oh, didn't register. Isn't that a horizontal line right there? Doesn't that cross at 2 places? Isn't that point 3, negative 3? And isn't that point 5, negative 3? So when it says, where does y equal negative 3? You're going to say that's going to happen when x equal a 3 or x equal a 5. So instead of doing this algebraically like we always do, we're going to do this graphically. Now, one more thing about graphs. They talk about increasing, decreasing. It says a function f is strictly increasing on an interval if you pick any two x's left to right, the y's are getting higher. The second y is bigger than the previous y, meaning if you take any two x's, the second y is above, that's increasing. Decreasing, the other way around. If you pick two x's in which this x is bigger than this x, then the first y is bigger than the second y, then you're going down. And constant, meaning you're not increasing nor decreasing, if you pick two x's and the y's are literally the same. I'll explain that more with the example. When I look at a graph, I read a graph from left to right. It says, identify the intervals in which the function is strictly increasing, decreasing, or constant. Anytime you're talking about a function, you're talking about a y increasing, y decreasing, or y being constant. You could write it this way, you could just say constant. So, Anytime I look at a graph, I read a graph left to right. This arrows continue. Remember, this author doesn't put arrows. If I read this graph left to right, if I'm walking from left to right, do you agree that I'm coming down as I move left to right? Coming down is decreasing. Y is decreasing on what? You want to label the x coordinates. How far to the left does this run? Isn't that negative infinity? And doesn't that come all the way to this value? Isn't that value 4? And then what happened from 4 and on? Do you see from 4 and on, you start moving up? We say there f is increasing. From where? From this x equal 4 to x equal, how far to the right is this going to run? Isn't this going to run all the way to infinity? 66. If I look at that graph, again, those are arrows. I'm trying to figure out whether it's increasing or decreasing. I'm walking left to right. If you walk left to right, aren't you coming down always? Doesn't that mean that f is decreasing from negative infinity to positive infinity? It's not increasing anywhere and it's not constant anywhere. If I look at number 68, left to right, we say f is, well, look what happened from left to right. Isn't that not, if you're walking left to right, isn't that constant? You're not going up nor coming down. So f is constant from negative 7. Do you see that's not included? Doesn't that run all the way to negative 2? And that's included. After that, you jump up here. Do you see that you're decreasing? And that's from negative 2, not included, because it's right there, to 0, included. And then what happened past 0? Don't you get on this path? Aren't you increasing from 0, not included, all the way to infinity? The last graph, if I read it left to right, do you agree that left to right, it's constant, but this is an arrow. F is constant from negative infinity all the way to negative 2, but it's not included. After that, do you see that you jump up here and you're decreasing between negative 2, it's included though, all the way to x equals 0. So those are always x values. And 0 is included. And after that, do you see that you're going to jump here and start increasing to x equal 2? From 0 not included because that's open to 2. And what happened after that? Don't you start decreasing again? Isn't that decreasing? So you're decreasing from 2 all the way to infinity. If you have more than one interval, don't you use a union? There it is. And there's your homework on that list.